All right, today we're going to be graphing lines. We're going to graph two equations on one axis, and we're going to observe the patterns that are occurring. So, number one, we have y equals 3x plus 2. So what is our slope?
No, 3 over 1.
And our y-intercept?
2.
2. So start at 2, go up 3, and over 1. All right, second line, y equals 3x minus 5. What is our slope?
3.
What's our y-intercept? So down 1, 2, 3, 4, 5, and then up 3, and over 1. All right, number 2, the first equation. What's your slope? And your y-intercept? So start at 0, down 1, over 2. And the second equation, y equals negative 1/2 x plus 4. So what's our slope? And our y-intercept?
4.
Start at 4, down 1, over 2. What are they?
I have the wrong notes.
All right, so what do you notice about them?
They're parallel.
Parallel. What does it mean to be parallel?
They're never, they can go
They're
never interstop.
They go along each other, but they never touch.
Exactly.
They're never like, ridiculous.
Yep. So, what do you notice about the equations?
They have
These ones have the same what?
slope.
And what about those ones?
Same slope.
So do you think that helps them to be parallel?
Yeah.
You have the same rise over run for each of these. We're starting at different places, but they have the same rise over run. So, parallel lines always have the same rise over run or the same slope. This is what makes them parallel. So instead of always graphing them, we can simply look at the equations, and if the slopes are the same in the equations, then we'll know that they're parallel. So now we're asked to identify each of the following as parallel or not parallel, and we need to put the equations in slope-intercept form first. So for 3, what's our slope? Okay? And the second equation? So are they parallel or not parallel? Because
They don't have the same.
they have different what? Yep.
Slope.
Slopes. For A, the first equation, y equals negative x. What is our rise over run? Negative 1 over 1. And the second equation, y equals negative 1x plus 6. What is our slope? Parallel or not parallel?
Parallel.
5, y minus 2x equals 3, and 2y minus 4x equals 16. So can we tell if they're parallel or not parallel yet? Yes or no?
Yeah.
Yes?
Yes, it's still a slope.
We what?
Isn't 2x the slope still?
Okay. How do you know for sure that it's a slope?
Because it's
As
times the x.
Okay. But we should have it in what form first? Not point slope,
Slope intercept.
slope intercept. So y minus 2x equals 3. What do we need to do to get it in slope intercept form? Add 2x. So y equals 2x plus 3. And that means our slope is 2 over 1. You were correct. So for the second equation, can you tell what the slope is usually? Okay. So 2y minus 4x equals 16. What do we need to do? Two y equals? And the last step? So y equals, so that means our slope is parallel or not parallel?
Parallel.
And 6. 3y minus 8x equals 8. Can we easily determine what our slope is? All right, so let's find it. 3y minus 8x equals 8. What do you want to do? So 3y equals? And then? So y equals?
Does that say 8 over 3?
Yep. So our slope is? Okay. And the other equation, 3y minus 4x equals negative 9. What do you want to do? So 3y equals? Now what do you want to do? So y equals? Minus 3. So what is our slope here? So are our equations parallel or not parallel?
No.
Not parallel. Questions? All right, graph the following lines. So for the first one, what's your slope? And your y-intercept. So we start at 2, down 2 and over 1. Second equation, what is your slope? And your y-intercept. Number 2, y equals 1/3 x minus 2. What's your slope? And your y-intercept. In the second equation, and the y-intercept, so what do you notice about the lines? Perpendicular, they are intersecting. They are what we call perpendicular. What does it mean to be perpendicular?
To be
Well, not necessarily. Perpendicular means what happens with the lines.
touch.
They intersect, but more specifically,
They cross.
cross.
They
they